Thanks for tuning into our talk about Cabaret. It's a tool we wrote that can possibly replace things like Git Fat and Git LFS. Before we jump in, I just need to give a quick disclaimer, and then me and Ryan will introduce ourselves. Use of names, logos, and brands does not imply endorsement by Airbnb, and the opinions we give in this talk are our own opinions. Now that the disclaimer is out of the way, I can introduce myself in case you don't know me. I'm BK on MacAdmin Slack. I'm on the client engineering team at Airbnb. We manage Mac, Windows, Chrome OS, iOS, Android devices. And my team loves writing tools in Go. We write a lot of custom client-side stuff in Go to manage Puppet and all sorts of other things. We really love Go because it provides static typing, integration with our company's monorepos. Just recently, there's been a lot of buzz internally about Go monorepo, and we get a lot of free code from other people that's useful for us. So we love integrating with that. And the first language that I started doing unit tests in is Go, and unit tests in Go are really easy, and there's nice frameworks for writing them. So that's another reason why I love writing Go, and so does my team. And now I'm going to pass it over to Ryan.
Cool. I'm Ryan, second time here, so thank you for being so welcoming. I also work at Airbnb on the security engineering team. I play multiple hats there, so I do a lot of endpoint security, but also infrastructure security. So my background comes with writing a lot of code in Golang and Python. But the infrastructure side, I have this love-hate relationship with Terraform, as in it's the best language out there for IAC, but I kind of hate it at the same time. So
maybe Henry can teach us to love it more.
Yeah.
And I want to give some credits to some people who are not here today. Nate Walk, who I think is watching the stream right now, he had the idea to rewrite Pantry, which is a tool that Facebook released a few years ago for doing a similar thing, managing binaries and source control. And he contributed a lot of code to the project and ideas. And he just really motivated me to work on it because he was willing to contribute. And he added Google Cloud Storage support in the tool. Me and Ryan started with local file storage and S3, and Nate was able to add Google Cloud Storage, so really want to thank Nate for his contributions here. And one thing you might be asking yourself is why did we want to work on this problem? Why was it interesting to us? So one reason that I wanted to work on it is I've used tools like Git Fat before, and there's a lot of fragmentation in the ecosystem for Git Fat and Git LFS. And there's some forks that support cloud storage, like S3. But I found the Git Fat code really hard to understand and complex and hard to extend. And so that was motivation for me to rewrite it and try to understand what's happening under the hood more by writing a tool that achieves the same. Another tool that I had considered using was Pantry, which I said inspired me to write this tool. But I wasn't super familiar with Python and didn't have a lot of experience. And it was just an opportunity to write more Go, to get better at unit testing in Go. And so I chose Go. Yeah.
Cool. I think for me, playing many roles in security, one of the best ways to kind of learn a platform like managing Macs at scale is working on problems with them. So for me, it was a hackathon for me. I was cool, let's work on a new problem. I think it's really important as well from a team aspect, to collaborate with other teams on wildly different problems. So I think that's why I wanted to help. And I was this seems really cool. So.
And I know we just said the ecosystem is fragmented, and we're adding another tool to the pile. So had to call out the irony there with XKCD. So another question that comes up often is like why you might want to manage binaries in source control in the first place. A lot of people say to like avoid doing that, but I'm gonna hopefully give some reasons why you might want to do that. So if you're running a service like Monkey, and Monkey has a dependency on you having possession of certain binaries, that dependency isn't always represented in source control if you're storing your Monkey configuration files in source control, but not the binaries. Like that dependency isn't clear if someone's just reading the code. Like what version are we running? Do we have the right binary available? So if you have a tool like Cavorite, you can represent the dependency properly in source control if someone is just reading the code. And that also gives you like team consensus is defined in source control. So if we decided we're going to upgrade to a certain version of a package, we can just see that in the Git history. And that also helps make things like rollbacks easier because you can see when something changed and how to go back in case you broke something. And in general, it's just a ledger for like decisions that have been made over time. And yeah, you don't have to argue about it. You could just git blame. Yeah.
More GitOps.
Right. Yeah, so I can introduce Cavorite, like our solution to this problem. So the term Cavorite is like a reference to H.G. Wells, but I never actually read any H.G. Wells, and I didn't know this word. ChatGPT suggested the name after some prompting, and there were only 10 other hits on GitHub.com for tools named Cavorite, so it seemed like a good choice. In the book, there's some reference about making stuff lighter weight, and in this case, we're making binaries lighter weight by replacing them with JSON metadata, so hence Cavorite. As I previously mentioned, Cavorite was inspired by Pantry. It's not a direct rewrite of the code that Facebook open sourced a few years ago, but it borrows a lot of design decisions like mapping cloud providers to interfaces and classes in a programming language. So again, like shout out to them for like showing off their ideas about how to do this. And like we use a lot of the same ideas in Cavorite. And now I'm going to give it back to Ryan to show us a demo of the tool.
Cool. So it's not a live demo, but it's close. It's close. We ran it just the other day. Just to kind of give an example, I'm going to give a little bit of a journey of like what we're going to go through here. So we're going to init Cavorite, which essentially configures the tool for us, defines the storage backend we're going to use. So as Brandon mentioned, we offer like these three at the moment storage backends. So S3, Azure, and Google. Probably never going to do Oracle, so sorry. Then we're going to do an upload. So we're going to upload a sample package. Shout out to the nudge talk from earlier because we're actually going to use the same package in our demo. And then we're going to retrieve it and download that from S3. Cool. So to start off our tool, this is after you like git clone it and then you build a tool. So this is how you invoke the tool. You'll see in the parameters list there, we have different ways of initting Cavorite. So here you can see the S3 address we have, the type, so it's type S3, and the region. For each different cloud provider, you have different parameters that you need to set, so it does that. As you can see, there's a little config here that kind of outlines how it works and how Cavorite will function. Cool. In this screenshot here, we're downloading the nudge package. So yeah, we primarily just picked this package because it was really small and it's very fast to run an integration test. So, but in this case, you can use any sort of package. It doesn't matter if it's a PKG, a DMG, it could be an exe file. It doesn't really matter. It could be any type. This screenshot shows us attempting to upload it. So you can see we define the package, PKG. We've shown this in the verbose debug mode so you can kind of see what's happening in the background. You can specify a folder, so it can be multiple files. It could be a folder, full of files, like a monkey repository in this case. And then the C file is that metadata file, that JSON metadata file that Brandon just brought up. So it shows our checksum when it was uploaded and the name of the package.
And then if you go back for a second, like at this point, you could commit that JSON file to source control and delete the package and then retrieve it later, like during your build process or when you're uploading to your actual web server.
Yep. Cool. Another way to just show this, we're just showing that the package was uploaded to S3, not that C file. So this is like the result of what happens. And to Brandon's point, this is the like GitHub showing the C files there, but not the actual package. So this is just the like the metadata that tells you how to get that package file. Cool. And then this screenshot is showing how we retrieve it. Again, this would most likely be ran by some sort of CI or automation tool to like download all your C file packages. And in this screenshot, we're showing that we're downloading it from S3. And then the below screenshot is showing that it has landed in our folder. We have a few lessons learned that we got out of this, and I'll kick it off with kind of the biggest thing I got out of this was like open source projects enable organic team formation. So really what I mean by this is that like at one point we all were kind of working like separate, and then like we just came together into like the Mac admin Slack, and like kind of the development process kind of like just kicked off organically. Like it was kind of cool. I don't know how many units of beer it took us to do it, but like it's just like really cool how fast we started moving and like building features out. And like that's my call out. Like we really moved quickly because like I don't think we were bogged down by like the business requirements all the time, like that slow us down, like design. We're like, cool, let's just build this out. And yeah, that was a lot of fun. So
yeah, we all just found something that was interesting to us and like decided to do it, which is awesome. Something that I really learned from this project is that like writing tests, particularly unit tests, and integration tests as well, are like fun, necessary, and they also like increase velocity. When I started the project just by myself, at first the README had like 20 steps of a manual process to make sure that I didn't break anything every time I added a feature. And as soon as like Nate and Ryan started working on it, like that really wasn't good enough anymore, especially if I wasn't like in Slack at the same time as them to tell them like how to test their change. And so tests help us like keep going at like a fast speed because they could feel confident that they changed something and it worked and go ahead like without me having to tell them that like, oh yeah, it looks good on my machine too. And another thing I learned as well, like I wrote a lot of, I'd written unit tests before, but I was never testing such complex things as like cloud storage. And it turns out like a lot of other people on the internet have written unit tests for cloud storage providers before. And people had built frameworks that they open sourced for testing storage APIs. And so I was able to just like reuse the work that other people did to create like fake Google Cloud Storage server and test against that so that like my integration tests will work even if I'm not connected to Google Cloud. And this like saves money as well. Yeah. If you're interested in checking out the project, you can grab it on my GitHub. And we're like happy for people to contribute, like send issues, or you can ask us about it in Slack as well. If you want to like learn more about Go and unit tests, you can check out the Golang channel on MacAdmin Slack. There's also channels for other languages as well. And we're happy to recommend like resources if you want to learn about unit tests. I've recently gotten really passionate about unit tests, so maybe I'll give a talk about that next year.